This is just a short video, I hope, to highlight some of the things that I was looking for in this discussion question 3 situation. So the point of this was to highlight what the average mean means and standard deviation means. And so in this case, we had two students, just short data set so you could focus more on meaning than on computations. So student one, pretend that, how did I say this? Assessing two students in their work with foundational mathematical ideas, and over the course of several months, the required assessments were given, and this is what happens. Student one gets a 25, and then he gets a 50, and then a 75. Student two, 49, 50, 51. Now, the tale of two students, it's a tale in this sense. There's more to the story than just looking at the scores. In both cases, there's forward progress. Student one goes from a 25, let's say these are percents, a 25% to a 75%. Student two goes from a 49 to a 51. So in the sense of making forward progress, they're both doing well. But there's something different about the two stories, isn't there? Student one, the data is more spread out, moving from a 25 to a 75. Student two, the data is more clustered or consistent around 50. So 49, 50, 50. Just 1 point separates versus 25 points separating. And so to measure these things statistically, we have in this particular case two statistics: the mean and the mean or average, same thing, and the standard deviation. So let's take a look at those two and make sure that they're being interpreted properly. I threw it into Excel just for ease. Now, student one, 25, 50, 75. Now, with the mean, you could compute the mean just by understanding what it means, the average, by understanding what it means. Remember, you add up all the numbers, divide by how many numbers there are. When you divide, you equally distribute. So if you look at this, can you imagine? Grab 25 points from here and move them to here. Did you see it? If you grab 25 points from here, that would leave 50. And if you put those 25 points here, that would be 50. Then all three tests would have been 50. That's what average means, equally distributing the points. And so you could have figured that out by just thinking about what average means without necessarily following the algorithm. And so student one has an average of 50 because here's what it means, if student one attained the same score on all three tests, that score would have been 50 in order to obtain the same total. Watch this. 75 plus 25 is 100, plus 50 more is 150. So it's 150 points total. Well, 50, 50, 50 also adds up to 150. Do you see it? When you equally distribute the points, when you say if the student scored the same on all three tests, what would that score have been? It would have been 50. Now, likewise here, can you imagine it? Grab 1 point here and move it to here. Then all of those would have been 50. And again, the idea of average is there. All the scores would have been 50. So both students have an average of 50. Suppose we end the story. They both have an average of 50. There's more to the story though. Averaging 50 by going from 25 to 75 is different than averaging 50 by going from 49 to 51. And so we have another statistic. In addition to the average, the equal distribution, or the it's as if all the scores were the same, in addition to that statistic, we have a standard deviation. Now here's how the standard deviation goes. Since it's a measure of spread outness, let's say it that way, since it's a measure of spread outness, we ask the question, how spread out from the mean, how far from the mean is each data point? So 25 points is 25 points away from the mean of 50 on the negative side. It's lower than the mean. 50 to 50 is exactly right at the mean, so there's no difference. And then 75 to 50 is 25 points above the mean. Or 1 point below, right at the mean, 1 point above the mean. So we keep track of those differences. But if that's all we did, what would we do with that to get a single statistic? Well, we could average those numbers, but if you take negative 25 and add 25 and add 0, you get 0. If you take negative 1 and add 1 and add 0, you get 0. They both add up to 0, so that doesn't really help. So what we do to get a statistic that's more useful is we square those differences. Negative 25 squared is 625. 0 squared, 0 times 0 is 0. 25 squared is 625. It's these numbers that we get an average. So imagine averaging these. And maybe you could add them all up and divide by 3. That's cool. And when you do that, you get what's called the variance, 416. Or in this case, add them all up and divide by 3. 1 plus 0 plus 1 is 2. Divided by 3 is 2/3, which is 0.66666, if you like. All right, that's the variance. But remember, the variance came from squaring the differences. And so to kind of return our data from squaring to not squaring, we take the square root. And the square root of this 416 number is about 20.4, and the square root of this 2/3 number is about 0.81. Now, you can see it with a standard deviation of 20 compared to a standard deviation of 0.8. Spread outness, this measure of spread outness is this data, this 25, 50, 75 is more spread out than 49, 50, 51. And the standard deviation just gives a number to help us to see, to quantify that idea of spread outness. All right, so 2 things just to recap. Average, if the students scored the same on all the tests, it would have been 50. Standard deviation, how spread out? With a standard deviation of 20 compared to a standard deviation of 0.8, student 1's data is more spread out. Student 2's data is less spread out. Now, that alone also doesn't tell all the story. Suppose student 2's standard deviation was low, but that's because they got a 98, a 99, and a 100. Now the data is clustered around the mean, but on the high side. Here the data is clustered, not very spread out, but kind of on the low side, 50%. So we're not claiming that it's better to have a small deviation or better to have a big standard deviation. We're just saying that it gives us a single statistic, a single number to describe how spread out data are. And for comparison purposes is really where it becomes useful. We can see bigger standard deviation, more spread out. Smaller standard deviation, less spread out. All right, that's the key thing behind mean, average, and standard deviation.